Welcome to the solutions for the AP Physics Kinematics problem set, problems 28 and 29. We start with 28. Tom the cat is chasing Jerry the mouse across the surface of a table that is 1.5 meters above the floor. This describes the displacement that's vertical, so we would label that as XY. Jerry steps out of the way at the last second, and Tom slides off the edge of the table at a speed of 5 meters per second. We assume that the table is horizontal. That makes this an initial velocity all directed in the x direction, so we'll label it VOX. Where will Tom strike the floor? This is the range of him as a projectile, so we'll label it XX. And what velocity components will he have just before he hits? So we are looking for not the final velocity, but the X and Y components of that final velocity. Okay? We're going to start after labeling our information here with a really well labeled diagram to help ourselves out. And so here we have the table, and there's the floor. We have the table 1.5 meters high, and this is our XY value. Here's Tom leaving with an initial velocity in the x direction of 5 meters per second. He travels as a projectile, and we're looking for how far out on the floor does he strike, and we're looking for the velocity components, and we'll address that here in a moment. All right, so if we look at this information, XX is the range. What do we need to calculate that? We need the velocity in the x direction, and we need the time. We have the velocity in the x direction, but we don't have the time. And as you learned, what motion controls the time in the air? And that would be the vertical motion. So this is a very typical horizontal projectile motion question in which you use the vertical motion to calculate the time in the air, and then you find the range using that time using the horizontal motion. So we're going to start off with here, XY equals VOYT plus 1/2 GT squared, using our equation that defines the motion of the projectile vertically. 1.5 meters is the vertical displacement. There is no initial vertical velocity because it's all directed horizontally, so the VOYT term is 0, plus 1/2 9.8 t squared. We double check, do we have any conflicting directions? The answer is no. The XY value is down, G is down, so we're all set here. Solve for t, following any necessary algebra steps you need. Pause if you need time to calculate, and you should get that t is 0.55 seconds to 2 digits. We'll use that non-sig fig value now in the horizontal equation. A projectile horizontally moves under conditions of constant velocity, and therefore the equation VOX equals Vx, which is the final velocity, equals XX over t. The constant horizontal velocity is 5. We use the non-sig fig value of our time, whatever that was, multiply, and we get the horizontal range, the XX value, to be 2.8 meters. So there's one of our answers that we're looking for. Okay, now the velocity components. Let's continue, let's do it over here to the right in blue. So if this vector represents the final velocity at impact, and we expand it out over here, what they're asking for is to find the Vy value and the Vx value at impact. Vx value we already know because we know that the velocity of a projectile horizontally remains constant. So we already know that answer is 5 meters per second. To calculate Vy, we need to use vertical information here. And what probably makes most sense is Vy equals Voy plus GT. V equals Vo plus AT. Just vertical motion specific. Vy equals 0 plus 9.8 times 0.55. You should use a non-sig value of that time. And when you do the calculation, we get 5.4 meters per second. So the horizontal component of the final velocity at impact is 5 meters per second, and the vertical component of that final velocity at impact is 5.4 meters per second. All right, let's move to number 29. A brick is thrown upward from the top of a building at an angle of 25 degrees to the horizontal. That's theta. With an initial speed of 15 meters per second, so that's VO. If the brick is in flight for 3 seconds, that's time. How tall is the building? And that's a vertical distance, so we will label that XY, and that's what we're looking for. All right, again, let's start with a diagram here, making sure we have a clear picture of what's going on in the question. So here's our building. We're looking for this XY value, the height of the building. Here's the brick, which is projected at an angle of 25 degrees with a horizontal and with an initial speed of 15 meters per second. This brick is going to continue as a projectile and is in the air for a time of 3 seconds. All right. What we should do before we continue this problem is we need to take and break our initial velocity into its 2 components to start with here and make it easier to continue with the problem. So we want the Vox component and we want the Voy component here. Well, the Vox component, how do we calculate that? Well, by now you should have it pretty well down that we're going to use cosine to do that because it's adjacent to the angle, and VO, the initial velocity itself, is the hypotenuse. So Vox is VO cosine theta, so that would be 15 times the cosine of 25 degrees. Go ahead and calculate that if you haven't done so already. Pause if you need to. And we get 13.6 meters per second. Likewise, VOY is the sine function to calculate it, since its value is opposite the angle, and VO itself is the hypotenuse. So VOY is VO sine theta, or 15 times the sine of 25 degrees, and that value is going to be 6.34 meters per second. You notice we carried both of those out to 3 digits to not sig fig ourselves on a later answer. Well, we want XY, so let's give it a shot right from the start here, that XY is going to be equal to VOYT plus 1/2 GT squared. Let's plug in and see what we got to work with here. xy equals VOY, which is the y component of the initial velocity, 6.34 in the air for 3 seconds, plus 1/2 negative 9.8, because in this question we do have conflicting directions. The 6.34 meters per second is upward, therefore we have to assign the g value, which is downward, the opposite sign, so therefore it's negative. T is 3, you have to remember to square it. Looks like we have everything we need to in order to calculate this question nicely in one step. Go ahead and do that. Pause and check your answer, and we get negative 25 meters. Now, you may be wondering, why is this the height of the building and not the total height of the projectile from the peak of its flight? Remember that this is displacement. So this is the vertical displacement, in other words, where it ends up relative to where the brick started from. If we take and mark over here, and I'll do it in blue, the brick actually has 0 displacement during that portion of the trip, up and then back to that spot. What's neat about this concept is that it takes that into account, and your answer is literally the displacement, the vertical displacement from the top of the from the top of the building, that is, from the moment it's released to the end of the trip. So the answer is 25 meters. You know also that it's negative because from that initial spot, that displacement is down, and therefore is consistent in that its displacement is negative. So the building is 25 meters tall. All right, more practice with projectile motion tomorrow in class.